why we explore Mars, and what decades of missions have revealed. In the 1960s, humans set out to discover what the Red Planet has to teach us. Now, NASA is hoping to land the first humans on Mars by the 2030s. Mars has captivated humans since we first set eyes on it as a star-like object in the night sky. Early on, its reddish hue set the planet apart from its shimmering siblings, each compelling in its own way, but none other tracing a ruddy arc through Earth's heavens. Then, in the late 1800s, telescopes first revealed a surface full of intriguing features, patterns and landforms that scientists at first wrongly ascribed to a bustling Martian civilization. Now, we know there are no artificial constructions on Mars. But we've also learned that until 3.5 billion years ago, the dry, toxic planet we see today might have once been as habitable as Earth. Why explore Mars? Over the last century, everything we've learned about Mars suggests that the planet was once quite capable of hosting ecosystems, and that it might still be an incubator for microbial life today. Mars is the fourth rock from the Sun, just after Earth. It is just a smidge more than half of Earth's size, with gravity only 38% that of Earth's. It takes longer than Earth to complete a full orbit around the Sun, but it rotates around its axis at roughly the same speed. That's why 1 year on Mars lasts for 687 Earth days, while a day on Mars is just 40 minutes longer than on Earth. Unfortunately, the planet is now wrapped in a thin carbon dioxide atmosphere and cannot support earthly life forms. Although water does exist on Mars, it's locked into the planet's icy polar caps and buried, perhaps in abundance, beneath the Martian surface. Somewhere during Martian evolution, the planet went through a dramatic transformation, and a world that was once rather Earth-like became the dusty, dry husk we see today. The question now is, what happened? Where did those liquids go, and what happened to the Martian atmosphere? Since the 1960s, humans have sent dozens of spacecraft to study Mars. Early missions were flybys, with spacecraft furiously snapping photos as they zoomed past. Later, probes pulled into orbit around Mars. More recently, landers and rovers have touched down on the surface. But sending a spacecraft to Mars is hard, and landing on the planet is even harder. The thin Martian atmosphere makes descent tricky, and more than 60% of landing attempts have failed. Early highlights of Mars missions include NASA's Mariner 4 spacecraft, which swung by Mars in July 1965 and captured the first close-up images of this foreign world. In 1971, the Soviet space program sent the first spacecraft into Martian orbit. Called Mars 3, it returned roughly 8 months of observations about the planet's topography, atmosphere, weather, and geology. The mission also sent a lander to the surface, but it returned data for only about 20 seconds before going quiet. Over the subsequent decades, orbiters returned far more detailed data on the planet's atmosphere and surface, and finally dispelled the notion, widely held by scientists since the late 1800s, that Martian canals were built by an alien civilization. They also revealed some truly dramatic features. The small world boasts the largest volcanoes in the solar system and one of the largest canyons yet discovered, a chasm as long as the continental United States. Dust storms regularly sweep over its plains and winds whip up localized dust devils. In 1976, NASA's Viking 1 and 2 became the first spacecraft to successfully operate on the planet's surface, returning photos until 1982. They also conducted biological experiments on Martian soil that were designed to uncover signs of life in space, but their results were inconclusive, and scientists still disagree over how to interpret the data. Together, all the missions have shown scientists that Mars is an active planet that is rich in the ingredients needed for life as we know it: water, organic carbon, and an energy source. Now, the question is, did life ever evolve on Mars? And is it still around? Future of Mars exploration. Once every 26 months, Earth and Mars are aligned in a way that minimizes travel times and expense, enabling spacecraft to make the interplanetary journey in roughly half a year. Earth space agencies tend to launch probes during these conjunctions. All of the robotic activity is, of course, laying the groundwork for sending humans to the next world over. NASA is targeting the 2030s as a reasonable time frame for setting the first boots on Mars, and is developing a space capsule, Orion, that will be able to ferry humans to the moon and beyond. Private spaceflight companies such as SpaceX are also getting into the Mars game. SpaceX CEO Elon Musk has repeatedly said that humanity must become a multiplanetary species if we are to survive. And he is working on a plan that could see 1 million people living on Mars before the end of this century. Soon, in one way or another, humanity may finally know whether our neighboring planet ever hosted life, and whether there's a future for our species on another world.